All right. Good afternoon, everyone, and welcome to our sixth review session. And this will be the last session for the quarter. And this week, all the questions are about capital budgeting. So I will first review the important investment criteria, and then we go over each question in the assignment one by one. At the end of the session, if you have any questions, feel free to ask me. Okay. So first of all, an overview, what is capital budgeting? It is the process of analyzing and selecting investment projects. Some examples include launching a new product, entering a new market, or acquiring a company or asset. These examples all involve decisions like capital budgeting. And the goal of capital budgeting is to maximize the value of a firm by efficiently allocating capital resources to projects that are expected to generate positive returns over the long run. So I want to discuss three investment criteria. The first one and the most important one is the net present value approach. In short, it is the net present value is calculated using this formula, which is the present value of benefits minus present value of costs. It measures the value added to the firm, and a positive NPV means the projects will increase shareholder wealth, and we should take the project with positive NPV and reject project with negative NPV. The advantages of NPV include it accounts for the time value of money because we consider discounts in NPV calculation. And it consider all cash flows, both positive and negative cash flows are included in NPV calculation. And it is a direct measure of value creation. However, because it requires cash flow forecast and discount rate, it can make the calculation very complicated in some cases. The next investment criteria is the payback period method. Payback period refers to the time required to recover the initial investment of the project. There are three steps to calculate payback period. First, we need to estimate the project cash flows, and then we subtract the future cash flows from the initial cost. And finally, we can identify when the initial investment is recovered. The decision rule using payback period is to accept the project if payback period is less than the cutoff time we defined. Okay, so the advantages for payback period it is simple and intuitive and is useful for liquidity decisions. However, since the payback period ignores time value of money and also ignores the cash flows after the cutoff time we chooses. So there is no clear decision rule for value creation, and the payback period method is less valuable than the NPV method. Next, I want to mention the internal rate of return approach. So IRR is the most important alternative to NPV. The definition for IRR is that IRR is the discount rate that makes the NPV of the project equal to 0. So here is the formula we need to use to calculate IRR. The decision rule is that we accept if IRR is greater than the required return and reject the project if IRR is less than the required return. So some pros and cons. IRR is easy to communicate as it is a rate of return, and its calculation is based on the it's based entirely on the estimated cash flows and is independent of interest rate. The disadvantages is that multiple IRRs occurs if there is non-conventional cash flows involved in the project. And it may complicate with the NPV calculation in mutually exclusive projects. So we will see this point in later questions. Since IRR is the most important alternative for NPV, we can compare these two approaches together. So we want to ask, when do they give the same decisions? So two criteria is that when there is conventional cash flows, meaning the cash flow size only changes once, and the projects are independent. So on the other hand, if there is non-conventional cash flows or there are mutually exclusive projects, NPV and IRR may give different final results. So the resolution is that if there is difference between NPV and IRR, we always rely on NPV approach. Okay, so that's a brief review of the investment criteria in this chapter, and we can move on to the assignment questions. The first one, this company imposes a payback cutoff of 3 years for its international investment projects. If the company has the following two projects available, should it accept either of them? So the key is that the payback cutoff is 3 years in this question. We are given the initial investment to be $35,000. The first step is to calculate the cumulative cash flows. In year one, the cash flow is $12,000. And in year two, the cumulative cash flow is the cash flow in year one plus the cash flow in year two. So we have 29,000 cash flows in year two. So using the initial investment minus the cumulative cash flow in year two, we are short of 6,000 in year two. So we are also given the cash flow in year three to be 14,000. So we can calculate the payback period as follows. It should be 2 years plus the cash flow amount that is short in year two divided by the cash flow amount in year three. So we can get the payback period to be 2.43 years. Next, we want to calculate the payback for project B. The initial investment is 45,000, and following the same procedure, we calculate the cumulative cash flow in year one to year three. And at year three, we are still short of $45,000 minus $40,000, which is $5,000. So following the same approach, we can get the payback period for project B is the first 3 years plus the cash flow plus the $5,000 that is short in year three divided by the cash flow in year four, which gives us the 3.02 years of payback period. Because the question defined the cutoff to be 3 years, according to the decision rule, we need to accept the first project and reject the second project. because it is greater than the cutoff 3 years, and the first one is less than 3 years. Okay, so let's move on to the second question. A project that provides annual cash flows of this amount for 9 years, which cost $63,000 today. So there are 3 parts. Is this a good project if the required return is 8%? And what if the required return is 20%? And finally, we want to decide at what discount rate would you be indifferent between accepting and rejecting this project. So here are some of the information we get from the question. First, we need to calculate the present value of the inflows, because the NPV is calculated as the present value of benefits minus cost. So the inflows, we are treated it as the benefit of the investment project. So using the formula of annuity, we should be very familiar to you because we have many questions about annuity in previous weeks. So here is the present value of inflows using annuity formula. And the NPV of this project is calculated as the negative outflows plus the positive inflows. So we can get the NPV to be about $10,000. Because this NPV is greater than 0, so we should accept the project. Next, the discount rate changes to 20%. And we follow the same steps with part 1. We can get the present value of inflows in this question to be about $47,000. And the NPV is calculated as the negative inflow, the initial investment, plus the present value of the inflows at 20% discount rate. In this case, the NPV is negative. So obviously, we need to reject the project. Okay, finally, we want to calculate the internal rate of return. So to find the IRR, we need to set the NPV of the project equal to 0. And the rate we get from this equation should be the IRR of the investment project. So with some calculation, rearranging terms, we can solve for the IRR to be 5.3848. Oh, we can calculate the present value. We can calculate the this should be the interest rate factor in the annuity formula. We should be 5.3, about 5.3. And next, we use a financial calculator to find the IRR, which should be 11.72%. So since the IRR is calculated as the discount rate at which NPV equal to 0 from this equation, at this rate, we are indifferent between accepting and rejecting the project. So a conclusion of this question, at the 8% rate, the NPV is greater than 0, so we accept the project. At 20%, NPV is negative, so we reject the project. The IRR of the question is 11.72%. And just as a review, the decision rule for IRR is that if IRR is greater than required return, we accept the project. And the decision rule for NPV is that if it is greater than 0, we accept the project. Okay, so next we moving on to the third question. Again, we want to calculate the IRR of the following set of cash flows. So as a reminder, and which is the same procedure we used in the previous question, we set the NPV of the project equal to 0. So the first term is the negative initial investment amount, and these three are the cash flows discounted back to year 0. So because this is a nonlinear equation and we must solve it using one of these three approaches, either use a financial calculator or use the Excel. Here is a function in Excel to calculate the IRR, or we use trial and error. So for me, I use the financial calculator and I get the IRR to be 21.77%. Okay, so I just list the decision rule here for your reference. Okay, any questions? If not, we move on to question 4. Consider the following two mutually exclusive projects. What is the crossover rate? So first of all, we want to find the IRR for each of the project. Again, it is found by setting NPV equal to 0. So the NPV should be found as the negative initial investment plus the cash flows in future period discounted back to year 0. So the IRR for project X is 18.29%, and following the same formula, we get the IRR for project Y to be 18.62%. So to find the crossover rate, we need to subtract the cash flows from one project from the cash flows of the other project. Please note that it is irrelevant which cash flows we subtract from the other. So here I just subtract project Y's cash flows from project X's cash flow. And after we do this step, we can find the IRR of the differential cash flows. So we in year 1, we subtract Y's cash flow from X, and we get a negative 1.5 thousand cash flows. And in year 2, we subtract Y's cash flow from X, and we get this amount. In year 3, we get a positive $100 cash flows. So we discounted back the cash flow differentials in year 1, year 2, and year 3, and set it equal to 0. We can get the crossover rate to be 8.11%.
Professor, I got a question.
Okay, go ahead.
On the previous slide, this slide, how do you find the crossover rate? I'm assuming that the crossover rate is indicated by R, right?
Yes.
How do you find it by hand? And
So I think for this question, you do need a calculator to do the calculation. So I didn't find it by hand.
oh, can you
So you
show me?
find the R from this equation here, right?
Yeah.
Okay, any other questions?
Oh, I do. I posted in the chat. So for this question, does it really matter which one we should use to subtract first? So since they're both our investments are the same,
Mm-hmm.
so is that matter? Should we use y subtract x or x subtract y?
Yeah, so
Would
I
would
mentioned
it
it here, so it
Yeah.
is irrelevant which cash flows we subtract from which. So you can also use project X cash flows, subtract it from Y's cash flow. So it doesn't matter the order of subtraction.
Okay. And the question asks for structure. Do
Okay,
we
so
have
yeah, it's actually not required for your answer. So when we grade assignment, we will not grade on your graph. So if you can show me this table of the NPV for the various required return is also okay.
But we have to do a table or a graph or not?
So I would say either a table like this or a graph is okay for this question.
Okay.
Okay, so for me, I just showed the table here for the which is the NPV for various required return for both X and Y. Or if you can draw the graph, it should show you the same thing. So the insight from this table is that project X always has a higher NPV for discount rate below the crossover rate. We calculated as 8.11% from the previous page. And project X always has a lower NPV for discount rates above 8.11%. So the cutoff is at the crossover rate. So here is just a summary of the result from this question. And we notice that the internal rate of return is misleading when comparing mutually exclusive projects, like we just find in this question. So in this case, we need to use NPV to decide. So the decision rule is that we always choose the project with the higher NPV at the relevant discount rate. So for example, if the discount rate is below 8.11%, we need to choose project X because it has a higher NPV. However, if the discount rate is above 8.11%, we need to choose project Y because it gives us a higher NPV. Okay. So we move on to problem 5. So in this question, we are given the project cash flow as in this table. There are two parts of the question. Should the project be accepted if the required return is 12%? And next, we need to compute the IRRs. And we need to answer, should the company use IRR for decision making? Part A, we need to calculate the NPV at the 12% discount rate. So since the cash flow is given in this graph, this one is the initial investment, show as a negative value. And these are the two cash flows in year 1 and year 2. So we discount it back to today. And the NPV should be found as this value. Since it is positive, we should accept the project. Okay, next we calculate the IRR for the project. Similar as we used in the previous question, we set the NPV in the previous question to 0. So here is the Descartes rule of signs. If there are 2 sign changes, there will be up to 2 IRRs. So in general, the number of sign changes implies the number of IRRs. So which means there are up to the number of sign changes of IRRs. So solving this equation, we will get 2 IRRs. The one is positive and one is negative. Because all the IRRs are correct and they make the NPV equal to 0, the IRR decision rule becomes ambiguous. Therefore, okay, there's a question?
Yes, I have a question, Professor. For the second IRR, when using the financial calculator, I only get the 26.51%, but how do you get the 78.59? The second one.
So what is your input for the calculator?
My input is for the CFO is -48.
Yeah, that's correct.
CO1 is 71 and CO2 is -13. I get
That's correct.
Yes, I get the 26.57 for the IRR, but how do you get the second IRR?
Okay, I will do it again myself after the session, and I will reach out to you my solution. Is that okay? So because
Okay.
I will do it after the session.
Well, yeah, I will need that too, because I have the same problem.
Okay, I can email both of you. Okay.
Okay, thank you.
All right.
Okay, so just to finish the discussion of this question, the correct approach if there's ambiguity in IRR decision rule is that we need to use NPV instead. Since the NPV at 12% is positive, the project is acceptable. Okay, so that concludes the discussion of the assignment 6 question. Are there any other questions for now? Okay, thank you very much for your time and see you tomorrow.
Thank you, Professor.
Thank you.